So I want to talk about what is actually a comet. Well, it's like an icy asteroid. It forms out beyond, the inner solar system, so down the outer solar system where ice is like a rock. It's so cold, ice is always perpetually solid like a rock, and so the comets are in that realm out there. Something disrupts them, their orbit, they dive in close to the sun. Remember, something can disrupt asteroid orbits. The major planets moving around can disrupt the orbits, even in the Kuiper belt. Indications are there's probably something similar to Kirkwood gaps out there too, and those things will just gradually get tossed into these elliptical orbits that dive around the solar system. And so what is the comet? Well, it's not just the tail. There's actually a solid thing in the middle. That solid thing is the nucleus of the comet. And so for a long time, there was a huge argument about what is this, so they were having this big argument about what is this nucleus. And Fred Whipple, American astronomer, comes along and he says, well, it's like a dirty snowball. So a comet is very much like a dirty snowball. It's a mixture of rock and ice. And it's probably all mixed together, rock and ice. His idea is probably a little bit old-fashioned today with how we really understand about comets today, but it's really not that far off, maybe. And because we also have indications that comets are some of them are very loosely put together and some are very solid put together. It's like it doesn't happen that often around here, but when you get a little bit of snow and ice and they put down the sand on the roads, then sand and salt mixture on the roads, then what happens is you drive through it and it kind of cakes up under your wheel well. And so you get out of the car and a couple of things can happen. It can be frozen in there solid like a rock. You got to chisel it off the car, and it's a solid rock of stuff. Okay. That's one of the problems here in the wintertime is that sometimes those things will fall off and then bounce and break someone's windshield. The other thing is that sometimes the stuff under the wheel well, you step out of the car and close the door and the whole thing goes sloughs and splashes on your feet because it's not very well put together at all. Comets are like that too. Some of them seem to be rock solid and others are very slushy, and so when they get close to the sun, they completely fall apart. And so the dirty snowball is probably not a bad analogy for these things. Rock and ice. By rock and ice, what do we mean? Well, let's start with ice. H2O, frozen water. But that's not the only kind of ice. In astronomy, we also take all these other things and call them ice. For example, carbon dioxide. That's dry ice when it's solid. It's not really ice. It's not H2O. But it's a gas. CO2 gas will be a solid if you cool it off enough. Methane. This is like a natural gas. That's methane. Methane will also freeze solid if you cool it enough. Ammonia will also freeze solid. So these are all ices. Carbon monoxide, even nitrogen gas, if you cool it enough, becomes solid, becomes ice. Okay. There's even indications that hydrogen can freeze solid. Well, it does. It will freeze solid. And so that can be a chunk of ice. And so all of that is considered ice, if you get cold enough. Silicates. That's rock. That's ordinary rocks or silicates. Silicon and oxygen combinations. Iron, nickel, little flakes of iron are in most meteorites. That's part of what makes up the propellant, and that stuff sinks to the middle of the planet. That's why we have an iron core on Earth. Carbonates. Ultraviolet light from the sun starts breaking apart all these things over here. Okay, so it breaks apart the methane, the ammonia, the CO2, and the water, and then what happens is all that stuff, the hydrogen, oxygen, carbon, nitrogen, all starts recombining to make hydrocarbons. Okay, we get carbonate rocks, we get hydrocarbon goo, we get all different kinds of hydrocarbons. Well, not just simple hydrocarbons, we get some complex hydrocarbons in here too. They've even found amino acids in the spectrum of comets. some of the meteorites we think may have originated on comets also have amino acids in them. Now that's the building blocks of life. That does not mean by any stretch of the imagination that comets are inhabited or have life on them. It does mean, though, that some of the chemicals necessary for life could originate in comets, which was always a big question of on this Earth. When the Earth formed, you're going to have rock and maybe water and iron, and so all those hard minerals like that. But how do you get life going? Because life on Earth involves nitrogen and carbon and all these other sort of things. Where does all that come from? And one possibility is a lot of that may have been brought to us on comets. So the nucleus is that solid thing in the middle right there. And so as the sun heats it, it forms a cloud of gas right there that's sometimes thought of as the head of the comet, or the technical term is the coma of the comet. Coma means hair. In fact, comet means hairy. Okay, so to the ancients, a comet was like a hairy star. Okay, the ion tail, the type 1 tail goes stretching straight out to the solar wind, and the dust tail goes curving off that way. And they can be long. They can be million miles or 10 million miles or more long. So they can almost be 100 million miles long. So they are enormous in terms of how far out they stretch. They're super thin. You can pass right through the tail of a comet and only bump into a handful of atoms and molecules. And so no big deal. In fact, that dust tail comes out there, and those dust tails continue to float around the solar system. And when they run into the Earth, you get meteor showers. Okay, that means that means in a particular night you get several little tiny meteors all from the same direction. And so that gives you a meteor shower. Okay. When in 1910, when the Earth passed through the tail of Halley's Comet, then a lot of people panicked because some of those amino acids form things like cyanide and things, but some of the organic molecules form things like cyanide and so forth. And so that was published in the newspaper that the cyanide in the tail of the comet and Earth was going to pass through it, and people thought they were going to die, and some people committed suicide ahead of time, I guess to get to the front of the line or something. But anyway, it turns out that scientists said, no, you actually release cyanide when you burn a candle, and you actually get more cyanide that way than you get through passing through the tail of the comet, because it is super thin. For all practical purposes, it's like a vacuum. Remember, the nucleus itself is maybe 10, 20 miles across, and you have a tail that's 100 million miles long. It can't be very thick. It can't be made of very much stuff. The water ice, the ammonia, the methane, the ultraviolet light breaks it down, and the hydrogen can come loose and form a giant cloud of hydrogen gas surrounding the head of the comet. And that hydrogen gas cloud can be almost 1 million miles across. And so it gives you an idea of the size of this. Now again, it's super thin, and it all goes down to that nucleus in the middle. The nucleus is almost never seen from Earth because the head of the comet, or the coma, shrouds our view of it. Okay. The two tails, ion tail, dust tail, already talked about that, and how they point away from the sun. Typically, the ion tail forms first. So as a comet is diving towards the sun, you get the blue ion tail. And as it's going away from the sun, you have the blue ion tail and the curved yellow dust tail. For most comets, the dust tail tends to be brighter than the ion tail. So your best views of comets are after the closest approach to the sun, as they're receding back into the outer part of the solar system. Now, studying those tails, however, helps to study the sun, because the tails were discovered to like wave and swing back and forth slightly as if they were in a gusty breeze. They sometimes got longer and sometimes got shorter. Sometimes pieces of them would detach and float away from the rest of the tail. And so that led astronomer Ludwig Biermann to postulate that there's a stream of particles radiating away from the sun, what we can now call the solar wind. So the solar wind, where all these particles streaming away from the sun, and we can actually rate the solar wind. We talk about the gustiness of the solar wind, the speed of the solar wind, direction of the solar wind. In fact, there's something called space weather that keeps track of all of this. And so here we have this idea that was intricately related to the sun, nature of the sun, and how the sun interacts with the planets. And no one knew it was there until Biermann started realizing that the waving comet tails were telling us there's something else that's out there. And he did this at the very beginning of the 20th century, long before he had spacecraft that could actually go out and measure the solar wind, which of course we have now.